All right, so for this one, we're talking functions on IXL. We are specifically talking the Q.4 identify functions, IXL. But I think you guys should be able to see that I have multiple tabs open up here and that we're going to talk about some other ones as well. So this may be a little bit lengthier compared to our typical one. However, I make some of the shorter videos a little longer than they need to be sometimes. Okay, so this is section 1.7 from our textbook if you're in my Algebra 1 class. And we need to know what a function is before we can do anything moving forward. So basically, a function is a relationship between an input, something going in, something happens, we get something out. So that's a little vague. So the only other thing on top of that is that each input needs a unique output. And to explain that a little bit further, we're going to flip over here to a vending machine. So let's make sure I got the writing tool on. So we have a vending machine here. And wish I was sponsored by this, but it'd be sweet. I'd be drinking, looks like Sunny D all day. Anyways, so when we have a vending machine, our input that we mentioned before is us pressing the buttons on the vending machine. Our output is, that one's a little bit more self-explanatory. It's whatever we get back out of the vending machine. We're going to assume the money's already in the machine. So that adds a little bit into it, but assume I'm buying for this one. Not in real life, though. So let's say we have a button like, you probably would say like A, and then a number or something like that, like row, and then the number to pick your choice, whatever beverage you're drinking from this vending machine. So like A1 would be this, looks like grape juice or something like that. C3 would be like the Sunny D, etc. So we'll say that's like A through E, and then 1, 2, 3, 4, 5, 6, 7, 8 across. So let's just pick a generic input, and then we'll kind of talk through it. I mentioned the Sunny D earlier, so let's go for this one. We're going to go and say that our input, let's see if you can see this, is, I'll say I for input is C3. So the C3 isn't anything mathematically, it's just the button you would probably hit to get this out. So that would spit me out a Sunny D. If I put in that input, my output would be Sunny D. You know, I never expected, oh, my writing's terrible on here. Never expected to write out Sunny D in purple on a math video, but sometimes life's unexpected. So from here, we've got to think about what would actually happen. I would hit the button. Theoretically, the machine would spit that back out at me. If that all happens, this machine is an example of a function. Now, if I hit the C3 button and it spits out a Sunny D the first time, and then I get thirsty later, and I'm like, man, I need a second Sunny D for the day. And I hit that same button again, and it gives me a Coke or something like that. Machine's broken, right? That would mean it's not a function anymore. So every time you put in the same input, you need to be getting the same output back. So every time I hit the C3 button, even if I plan on drinking 10 Sunny Ds in the day, it should give me one back every time. Something that is allowed with a function that might not be self-explanatory, though. Notice that there are some other places up here where I could get a Sunny D. So let's say that one runs out. I drink all the Sunny Ds from that row. If I put in another input, and let's say I put in A, 1, 2, 3, 4. I'm going to put in A4. My output would also be a Sunny D. That's allowed. So you can have inputs that give the same output. That's okay. But again, I wouldn't want to say input A4 Sunny D, input A4 Sunny D, input A4 root beer or something like that. that wouldn't be okay. That would mean the function's broken. So let's take this and try to apply it to some numeric values now, some numbers, and we can potentially flip back and forth. Okay, so this one's called identify function, so we just need to decide yes or no. If we think about it like a vending machine, is the machine working or is it broken? Is that okay? Is it something that's allowed or no? So the X's, the left-hand column for a table, is going to be our input. So that's like our button we press. And this is the output. So that's compared to like the beverage we'd get back from the machine. So if I press the 12 button instead of A4 or whatever, if I press 12 and I get a 7 back, sure. If I press a different button and get a 4 back, that's fine. But if I press that same button again from the beginning, so I hit the beginning button a second time and I get something else back, that means it's not a function. That would be like if I hit the C3 button, got a Sunny D, hit a different button, got a Coca-Cola, maybe I was feeling that later, went back to the Sunny D button, and it gave me a water. It means the machine's broke. That also means it is not a function. So that's kind of the thought process there. And you could even tell yourself that kind of vending machine example with like every single one of these that you do until you get used to it, maybe. Okay, so this one, it's called mapping, when we have like the box and we say domain and range. So basically follow the arrows. It's not anything crazy complicated as long as you know what to look for, and that's the arrows. So from what this is telling me is if I press the 9 button, it's going to spit a 4 back at me. Okay. If I hit the 12 button, it's going to give me an 8. That's fine. It's its own thing. It's unique to that. If I hit a 1, it's going to give me a 2. If I hit a 1, it could also give me a 16. I don't know about you guys, but if you've ever hit the button on a pop machine or something and got back you're really wanting a Mountain Dew, you got a Mountain Dew and then you go back to that same machine, hit the same button, and it's a mystery. That's not good. You don't want to be hit with a Diet Mountain Dew if you don't want to be drinking that. So this is another example of the machine being broken. It's not a function. The machine's not supposed to spit out 2 different things for the same button. So that would be another example of no. That's kind of how we could tell there. Okay, now we have it in a graph form. So you notice that we can represent this in a couple different ways. And I think that's from the 1-6 relations section. It kind of talks about these different ways, mapping and graphing, etc. Okay, so we need to remember that these are the x values left and right, and the y values are up and down. So if I have an x value of, this was probably 0, and it goes with 1, okay. I don't have any other x values of 0, so that's unique. A 3 goes with a 3. A 4, 5, 6, 7, 8 goes with a 0. 9 goes with whatever's up here. Those are all unique. There's nothing that's in a line from each other. That's another way to tell that we'll talk about. So this is an example of a function. There's nothing where I would have an x value of 0 and get a 4 and then a 0 and a 1. So that means we're actually good here. Okay, here's kind of what I was just talking about. Lucky that it worked out that way. If I go to the x value of 1, I could get a point that has a y value of 0, or I could go to the x value of 1 and get a y value of -1. So that's given me 2 options. We just got done talking about how we don't want that on a vending machine. We don't want that with a function either. So this would be an example of no. And then I think the ordered pairs is probably the last way you would see it represented. These are our x values first, and then the y values. 19 goes with 1, but 19 also goes with 2, and 19 also goes with -10. Doesn't work. Something I'll point out real quick that is allowed, just in case you see it, is if we had 13 with -19, and then 19 with 1, and then if they hit us with 19 and 1 again, and said, is this a function? just these three, that's actually fine, even though you see 19 twice. The reason being, it gives you the same thing both times. That's like when I got really thirsty earlier and was drinking a Sunny D, and then I went back for a second one. As long as I get the same thing back, that's fine. So the new one that I wrote out, that is okay. This one's not, because these are different. Okay, that's clear. So I think we went over everything this one has to offer. I'm going to flip now to, let me make sure I'm on the writing tool again, to another IXL that you might look at, Q5, so the next one in the order. This is something called the vertical line test. So this is kind of what I was talking about with the two dots that shared an x coordinate earlier. Anytime you can, let me rephrase that. If I draw a vertical line in here and I only hit their line, the blue one, once, I'm good. So that means it is a function. Oops, wrong thing. So that is a function. However, this is another example. Vertical line here, only touch once, only touch once, only touch once. There's nowhere where I would hit more than once. So this is another example of a function. Let's skip ahead a little bit. Make sure we see one that is the opposite case. Okay, so this is like a multiple choice or a select all that apply, I believe. So let's look at the circle first. If I draw a vertical line anywhere through that, I'm hitting it twice now. And that actually occurs in multiple positions. That only has to happen once for it to not be a function. Because if you think of whatever x value is like right here, it gives you some y value. This is the same x value, different y value though. So two different options, that's not okay. The next one over here, although I'm safe right here, I'm not safe in the middle right there. So that tells me, again, not a function. Same thing here. I don't know if I can draw a straight enough line, but if you just hit that single point, it would be fine. But the fact that that we crossed twice over here, again, not okay. What that leaves me with is this fourth option. That's the parabola. That's a U-shaped graph. That one is fine. So that's called the vertical line test, and you can tell if it's a function or not a function. Let's look at one more thing here. This is Q6, the next one in the order. So this is kind of an important section. You can tell that I'm going through more than one thing. So for this one, it wants us to find values on a graph that they're going to give us. So if the x value of our function is 7, you got to remember x goes this way, it tells you. So if I go over to 7, basically what it's asking for is how far up or down do I have to go till I'm on that line. So I follow 7 up, 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 up. So right here, I look, what's the y value right here? 6. So that's what it's asking me for. What is the y value at this point? That's 6. Oops. Did not finish the question. I'm going to hit yes and see what happens. Correct answer is 6. Okay. I don't know why I didn't take it, but we'll do another one. You get to see the pitfalls as well. Plot the point. Oh, I didn't hit the point on here. I just put a dot with my finger. That's what happened. So you got to be careful with the IXL instructions, kind of like I didn't right there. I'm sure it happens. Plot the point on this function with an x value of 3. So I go over to an x value of, well, in between 2 and 4 would be 3. I go up till I'm on their line. I plot the point this time and not just hit it and draw it with my finger. I realize I'm at the y value of 2, so that's what goes in the box. And it should let me actually submit this time. Excellent. Okay, let's move forward a little bit. Let's see what other things it may throw at us. Okay, so we have an upside down parabola now. Plot the point on this function with an x value of 5. So I go over to where I'm between 4 and 6. I go up till I'm on their graph. I plot the point this time again, and I realize I'm at a y value of 2. So I just go over and see where I'm at. Okay. Let's jump forward again. Plot the point with a y value of -8. So you got to be careful and read what they give you up here. So y value means I'm going up or down now. So I'm going down to -8. And then I got to look how far left or right I go until I'm on their line. I plot the point again. And then I realize I'm at the x value of 2. So I can follow my cursor up there. And I can type in 2, that's the x value, and hit submit. This will probably be the last one for this video. I know it's running a little long. Plot 2 points with the y value of -4. So I got to go down to -4. I go over till I hit the line, boom. But what we should realize when they ask us for 2 points is that if I keep going at -4, I hit the same graph again. So that means I have 2 different answers down here. I have the x value of, follow that up to 3, and 8. So I need to make sure I put both of those in. And my assumption is the order doesn't matter as much, but I'll put the smaller one first and then the bigger one, numeric order. Okay, so we'll close it out here. Like I said, this is one of the more important sections that we bring up multiple times throughout the course, and then moving into Algebra 2 as well. And I know that it's a common test subject as well, so that's why we like to stress the function section. Hopefully the vending machine made sense, and I wasn't just rambling about Sunny D for like 10 minutes, and hopefully it kind of compared it to something realistic. All right, we'll close it out here, and looks like moving forward into section 1.8, we have, looks like we're getting into graph stuff, so close it out here, and we'll see you.